practice problem number 5. If you haven't already, go back and read the little bit on the hypothesis test for matched pairs. That's what we're about to look at. So we saw a hypothesis test for independent groups, one where we needed a z-score, one with a t-score. If you look at that formula for the test statistic for matched pairs, notice it's only a t-score. So we'll make sense of that in this problem right here. Let me go ahead and read number 5. A college athletic trainer believes by taking a special vitamin, weightlifters can increase strength. I want to know what that is. 8 athletes are randomly selected and given a test of strength using the standard bench press. You may know a bench press, pretty fundamental movement in weight training. All right, after 2 weeks of supplementation with the vitamin, the athletes are tested again. All right, so let's pause here. How would we know that this is a matched pair situation if it wasn't already made obvious to us? Because it's the same athletes. They take the 8 athletes, they test them, then they give them the vitamin for 2 weeks, then they test the same 8 people again. So there's this very clear match. So it doesn't matter how much weight they can bench press before. All we're looking for is, did they get stronger, right? So we need to take the same people, of course. All right. So we get all that data. We see the data for each of the 8 athletes, and they already specify the groups. The before group is group 1. The after is group 2, and we can see how much they either improved or didn't improve on their bench press from one test to the next. And then we see test the claim that the vitamin will increase strength at alpha equals 0.05. All right, let's get into step 1, the null and alternative hypotheses. Hey, our null hypothesis, it's always going to be this. mu1 minus mu2 equals 0. The average for group 1 minus the average for group 2. It's the same people, but it's 2 weeks later, right? We are going to assume that this vitamin does not do anything for strength. It doesn't help it. It doesn't hurt it. So the average here and the average here are equal, or you might say 1 minus the other is 0. What is the alternative? Okay, so we repeat this part. mu1 minus mu2. We repeat the 0. Is it a greater than, or is it a less than, or is it a not equal? Let's look back at what they said. In the question itself, test the claim that the vitamin will increase strength. So if they increase strength, which way is the inequality going to go? And this is like counterintuitive for a moment. If they get stronger, isn't this going to be the bigger average? Group 2 is after 2 weeks of this vitamin. If they get stronger, they're pushing more weight, right? Their average is higher here. So this is actually going to be less than, because the first test should be less than the second test. That's easy to mix up. Okay. Let's move on to step 2. Now here's where we can make sense of that test statistic formula. I'm just going to write it out here and talk about it. You notice it's the same as the central limit theorem. Of course, we have S here because it's a T. We have all these sub D's. What are all these sub D's? That stands for the difference. Okay, so what is that all about? Here's what we're going to do. We're first going to find all of the differences. Here's what I mean. We're going to look at the difference of each athlete between their 2 tests. So capital D sub 1 is athlete number 1. He started off at 210. 2 weeks later, he was able to bench press 220. So group 1 minus group 2, negative 10. He got stronger. We're going to do this for all 8 athletes. So then the next one, the difference for athlete number 2, 230 minus 235 equals negative 5. Okay, once we do it for all 8 of them, let me put all this up here. I'm just going through each of the 5 and finding all these differences, okay? So in number 3, I think he didn't change at all. He was 180, 180, difference of 0. Number 4, he actually lost a little bit. So his difference ended up being positive. And then, okay, back to negative and all the way down. And finally, number 8 didn't have any change. So he's at a 0 also. All right, once we have all of these differences, think of this as 8 pieces of data. All right, negative 10, negative 5, 0, etc. We're going to put those numbers into StatCrunch, and we're going to find the average, and we're going to find the sample standard deviation. And that is X bar sub D and S sub D. And these are the numbers that I got, so I will invite you, maybe pause the video, put these 8 numbers in to StatCrunch, get your average and your standard deviation, see if you can confirm these numbers that I got. Okay, so we're going to put those in. I've got this right here. So we're calculating. By the way, we can tell here that it's got to be a t-score because we're finding a sample standard deviation, right? That's all we've got to go on. Okay. So we've got the negative 2.5 minus 0. Hey, back up here. The difference of the mu's. Well, we're assuming that difference is 0 again, just like in the other examples before. So we've got negative 2.5, 0. We've got our sample standard deviation divided by the square root of our sample size here. The sample size was 8. And if you calculate that whole thing, you'll get a t-score of negative 1.18. So the idea, like the big difference in how you calculate the test statistic of the matched pairs versus the independent groups, the independent groups, like we're taking the difference right there. We're subtracting here, and we end up adding, and doing this funny thing to the denominator. But it's like we think of the averages first, and then we take the difference of the averages. Where in matched pairs is actually way better. There's less variability because it's the same subjects. So we're able to take the differences first and take the average of the differences and the standard deviation of the differences versus the difference of the averages. That's a better way to go about it if you're able to do so. Okay, more reliable. All right, let's go to step 3 finally. Step 3 is the p-value. So, of course, we use the t-calculator. We had negative 1.18. Our sample size was 8, so we need 7 degrees of freedom. And now a very important moment. Is it a less than or a greater than? Right there. Well, if you recall, back in our alternative hypothesis, we had mu1 minus mu2 less than, or it might give it away that we've got a negative test statistic, so we need a less than. you can remember it that way as well. All right, putting that in with 7 degrees of freedom should get you 0.1383. I think I rounded that. And okay, moving on to step 4. Let's compare our p-value with alpha. Well, our p-value is bigger here. No question about it. So if the p-value is bigger, which decision do we make? Reject or fail to reject? We fail to reject this null hypothesis. There is not enough evidence that this vitamin will increase strength. It seemed to work for several of the athletes. Definitely not all of them, but maybe half of them it did work. But apparently that is not enough evidence given how much they improved and the fact that other people did not improve, or even one person, his numbers went down even. Okay, anyway, we're right there. We are going to stop this video here. You'll notice I talk about the confidence interval for matched pairs, but we don't have a practice problem with it. Use that when it comes up in homework or in your final project. Read the part about the hypothesis test for two proportions. We're going to do that last example next.